Hello there, my mate Vince here, and welcome to another Advent Potential Fix. So we're looking at a foot and calf massager with heat by Neck Tech. I bought it faulty from eBay and it was sold as a new item but not working. Box with a little damage. Well, the box has certainly seen better days, but the item itself does look pretty much immaculate. Now, I've watched a review on it, and apparently when you plug it in, it should just come alive down here, but all I've got is this little flashing red power light, and when I press it, it makes a noise, so the touch panel's working, but there's nothing coming up here. So I believe that should be green. Interestingly, we have a little remote control here with batteries in, and there's no lights on here whatsoever, and it's not doing anything. So yeah, I'm not too sure what's wrong with it. It's only fed from 12 volts, so it's not mains. So I'm hoping there might be a chance of fixing this one, because often when something is fed from mains, it just seems to explode on the inside when something goes wrong. But with this, maybe it might be straightforward. So let's get over to the mat and find out why it's not coming alive. Okay, I've just reinserted the batteries, and now we do have lights here, but it's still not coming alive on the unit itself. The spring terminal looks a little bit low, so we will have to try to push that up a bit. It's still the same thing though, it's just beeping without actually doing anything. So whether we hit that or this makes no difference. It's a bit of a big bertha, this one. Now, I was having a look at the side, and it doesn't say what the input should be. It just says power connection point or port, and on the bottom, interestingly, well, we've got a pat testing on it, and it says that the input is like mains, and it's not mains, it's low voltage. So yeah, I don't know, but anyway, if you have a look here, I was wondering if a different power supply has been sent with it, but it clearly says Neck Tech here on the power supply, so it must be right. And it says output 12 volts, and I've put my multimeter on it, and it certainly is 12 volts. So it looks like the power supply side of it is all right. There you go. So I think that's going to be fine. So let's take it apart and see if we can find out what might be wrong. So there's loads of holes in the bottom, but there's not that many screws. I undo 4 screws and also 2 screws for the feet as well, and nothing's coming apart. So let's flip it over and see if there's any screws from the top. So let's undo these zips and see what that uncovers. Okay, so I can see a pipe here to allow these things to pump up. And we've got a load of screws. Oh, here we go. We've got screws here as well. So forget about these little ones, but I can see another screw here and here in the corners as well. And we've got some weird thing in here. Some cylinder shaped thing. So this cylinder thing actually is the vibration feature, and then underneath the feet it's got some kind of rolling sensation feature, and then we have these pads either side of the feet that blow up, and also we have heat as well. So this thing does numerous different things. The idea is you just sit down, you put your feet in it, or you can put it up on its stand and then you can put your calves into it, and then it will do all those features but on your calves rather than your feet. Now this thing is held together with a ridiculous amount of screws. Think PlayStation 5 and then double it, and that's what you've got here. So I'm just undoing screws for what seems like the next 15 or 20 minutes, but finally we have access to the insides, because I want to get up to the touch panel to see if there's anything wrong with it, or at the very least the insides to see if there's a loose wire somewhere. This is a new item, so I'm thinking there can't be too much wrong with it. I'm nearly there. I think this is the last screw. Right, that should be done. Yes. Well, fair play. It's an Epic, as in PlayStation 5 Epic, but wow, look at this. But there's no clips, which is really, really good. Whoa, look at this here, a mini pump. What's the pump for? Oh, of course, to do the air, to do the inflation. So now, I think I need to get to the very top bit. A very hard thing to film, if I'm honest with you. Let's just make sure everything's plugged in, because I think I might have been the first one in there. There's a little board down at the very bottom, just here, and there's a board up the top. So I want to get to the touch thing up and I'm going to lose all the screws everywhere, aren't I? Let me just knock them out. I don't really know what I was expecting inside, but this looks pretty impressive. These are for the little heat things here. Then they go down to here and here for the heat. Let's undo this board here. That popped off nice and easy. Where does that go to? That goes to the bottom board. So I suppose at least let's take off the top board and then maybe we can put it on the bottom board and do some touches and stuff and see what's happening. There we go, top board is out. And that's how it recognises the touch. So let's put this board down here. And let's take this out. Let's plug it back in. And I suppose let's have a close inspection here, and really we need to look at the bottom board as well to see if we can work out what's going on, because it's getting some form of life but not much. I think we'll zoom in. Let's do a visual check to begin with, because right now everything really is looking brand new. So these are obviously a load of motors. Oh, the gearbox is in here. Ah, so this is the gearbox in here, which is turning this one and this one. I don't know whether they're the same speed or different. And then this is a little, you know, kind of like a piston on a crankshaft, yeah? Doing that, that's going to be moving that. So you put your feet here with pressure. That's going to be doing your heels, the middle, the arch, and your toes, I think. Now I wonder, is something putting a short, maybe something's putting a short on and stopping it from turning on. So I tell you what we'll do. Let's unplug everything from the board. I'm just going to take a picture and then we'll see if it comes on, and then we know, because it might be this thing here that's putting a fault on. That's a good idea. I'm just going to take close-up pictures so I hopefully will see what wires go where and the colours in case they're reversible. So I am going to unplug everything apart from this and the bottom board and the power connector. So the power connector comes from here. I don't know how much of this you can see. Power connector comes from here and goes under. So it's this one here. This is the power connector here. So let's leave that plugged in and let's unplug everything else. So out comes the motor. Right, so that's everything unplugged now apart from this top board. So now I'm going to plug it in and see if it works. I feel safe doing this because it's only 12 volts going in. So plugging it in now. Right, red light, flashing. Still flashing. So now we know it's nothing else affecting it. It's something on this board or the board down there, which is slightly worrying. Also, when does it make the noise? Yeah. Okay, well, might as well unplug it again. I think we need to take both boards out and have a very close look. Okay, I've undone the power connector from here and I've just pulled it through there. So now we can work on this on its own and we can get this massive big lump out of here. Ah, that's better. That's what you need for a blue mat. That's much easier. Right, first things first, let's have a visual check. See if we can see anything obvious. Just looking for burnt components. Or any water damage maybe? A lot of flux around here, but maybe that was when they soldered up these springs. All around here, but it could have just dripped down. Maybe we should get the flare cam on and see what's heating up. Okay, so we've got a separate board soldered on here. Do you reckon that's for the remote control? Because the remote control doesn't have a little IR thing up here. So I wonder, is it some Bluetoothy typey thing? Maybe that is what that's for. Unless there's something on here. Right, well, that to me looks okay. Let's have a look down here. I wonder is U1 a voltage regulator? Looks a little bit black around the edges, so I might come back and test that. I think this is just a glue. Well, I can't see anything dodgy or iffy there. What we got here, nothing. So I think we'll plug it in and see what. Let's get the flare cam on. Well, hopefully this might show something up. Oh, yes it does. But it's not hot, but it's that voltage regulator. Okay, good, we've got something to go on, but a voltage regulator would get hot. Let's try this one here. Nothing there. So the only thing getting hot is, let's use some plastic because it's plugged in, is, hold on now, this thing there. Yeah, the voltage regulator. Okay, well I did say that looked a little bit black. Nothing there. But look, if you, let me check this side. Slight bit of heat, or is that reflection? Up here, no, I think that's just reflection. No, that's reflection. But look, when I bring my finger in, can you see my finger's much hotter than it? So it's not warm. It's a little warm. I think that's probably normal. So maybe if the voltage regulator was playing up, it's enough to have it in standby, but not enough to actually start it. Right, let's see what's happening on this voltage regulator. So I am going to go to begin with on the input here, and let's just see what we got. So nothing there, so that might be the grounds. 5 volts there. And 11 volts there. Well look, we've got the 5 volts coming out. So is that 5 volts going up here? I bet it is. No, not on that one. 5 volts is on the green, not the red. No. No, unless it's been wired up wrong. So we've got, let's go across to black and the green. Black and the green we have 5 volts, but black and the red we don't have anything. That's a little bit odd. So let's go to here. I think that voltage regulator is working fine because you've got 12 volts coming in, you've got 5 volts coming out. So now, what's happening here? 5 volts there. Nothing there. Let's go on to, when I press that, what is shorting? I think. So you can see the spring goes through the board, and can you see there's a little via just here, because there's nothing on the springs there, but there is a little via here. That via goes down to another via there near these 4 contacts. So I think it probably goes to maybe the blue. So I wonder is when I do that, because even that's not happening all the time. I wonder is the signal not going down the blue? not happening at all now. I'm just going to unplug it, plug it in again. Let's see now. So is that going down the blue? Tell you what we'll do. Let's kill power. And let's see if we can work out. See, I hope these haven't been put in wrong. Maybe it's never ever worked, you know? I just think it's weird that it's going down the green. That 5 volts is going down the green. Don't you? Let's see. So basically, green is going to be the second one along. Let's see where the second one along goes to, and it might make more sense. I'm just going to go to continuity. So the second one along, to be fair, does look main. So that goes to here. So we could check this to see if this is outputting. This might be another voltage regulator. And then it goes across to this sounder. Then it goes down to here, comes round, goes into this. Where would that go to? The lower one. Along back to here, over to this area. Well, let's plug it in and see what voltage we have on this, because maybe this isn't outputting any voltage. Maybe this is a 3.3 volt regulator. But yeah, the green does seem to be the main one. Hold on. Yeah, 5 volts there. What's here? Nothing. What's here? That should be the 5 volts. What's here? 3 volts. That's right, isn't it? Now what happens if I press this? Oops. Be careful not to short anything. Right, let me try and press it. Not going to press now, are you? Let me unplug it and do that again. I just want to see if it changes when I press it. It doesn't want to work now. That's a tough one. So I'll do a little bit of fault finding to try to work out where the on and off switch goes to. It goes through a load of wires and stuff, but eventually after going through a couple of resistors and capacitors, it ends up at one of the chips. So let's look up what this chip is, and then maybe we can check for voltages at the chip. SC098 or B I think. SC09B. Right, interestingly, they are touch screen controllers, so I'm going to see if I can get a data sheet and see if I can work out. Maybe we can just short that pin to ground, and well, mind you, that's what that spring's doing already. So yeah, I'm now wondering maybe if the chip's at fault. Well, I have found the data sheet. I've gone through 2 different places, and it's both in what I presume is Chinese. I haven't got another phone to translate off this because it's like 1:20 in the morning here in the UK. Everyone else is in bed. I have got this little sheet here though, but I don't know what voltage and stuff it's supposed to be, this little diagram. But what I could do is, I presume that that's going to be the voltage in. Yeah, because that's pin 1 here. So no, that's ground. VDD is going to be voltage in. So let me connect it up again, and let's see at least if the chip is getting the voltage, because if the chip's not getting the right voltage, that would suggest why it's not working. It's just, the thing is, it is working, it's recognising the beep, it's just not turning on. So it might not even be a problem with this board here. See, if you fixed these all the time, you would have spares, and straight away you would just swap the boards about. And for example, I'm spending all this time on here, and the fault will probably end up being on here, but I'm just trying to trace the power back because I don't know what else to do. Okay, so still not turning on. I just want to see, is it flashing like that? It was flashing like that at the very beginning, wasn't it? Yeah. Right, let's go on to here. And let's see if we have voltage going to here. Ooh. Ooh. Yeah, we do. Hold on. 5 volts we do. Okay. Right, I am going to go to, where's my ground gone up here? So it kind of looks like red is the ground. Let me just see that. Yeah, 5 volts. Is that also ground there? Yeah, 5 volts there. So we've got 2 grounds, possibly. Let me go to here, and I'm going to go to my one on the chip. I want to see what happens when we press that button. First of all, let me just double check here. So I'm in the right one here. So now, here. So it's 0.3. What happens when we do this? So it's not allowing me to do it. Ah, when I pressed it, it activated it. Yeah, so I'm not pressing it now. That's just me doing this. Would it do it without that lead there? Yeah. Okay, so this turns it on, but where does that send the signal to? So it looks like these are all the inputs then. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like we've got 9 inputs. But I don't know what the rest of this means. I presume that's some sort of clock. Serial clock, serial data. Don't know. Interrupt. Not sure. I don't know what CDC is. Or CMOD. Okay. Not really getting anywhere. So out of desperation, I turn to isopropyl alcohol and I give the board a nice good clean because there is a lot of flux around the place, and just in case it's getting some kind of rogue signal or something, because the flux might be conducting where it shouldn't be, I give it all a good clean. But guess what? It makes no difference at all. So I turn my attention to the other main board, not the little touch board, but the other main board, because we have a chip on there. And I presume that's the brains of the operation. So I want to see the relationship between the touch board and that chip. Right, I'm just tracing the wire. The red wire here is definitely ground because look, red here, which is the top pin, and you can see this is all ground here, and that's coming up here, yeah? And then we know the output here is the 5 volts. That comes here, which is definitely the green. And then I thought black might be ground, but it's not. Black goes to this resistor. And then if we go from this resistor, it goes all the way down here into down this one here, and it goes to here. And then this one, which is the blue, goes to this resistor, and that one goes down to this hole via, and then it comes up here. Yeah. So we need to find out what this is, because I'm wondering whether the we know that these two are the power. Maybe these are what's telling this chip what button's been pressed and what to do, i.e. turn on, put heat on the feet, you know, pump up the side bits, different pressure off roller, etc. So I think we need to look up, because I mean, what else could it be? This just looks like power MOSFETs for the motors. Maybe there's some sort of triax or some sort of H-bridge controller or something like that, because I'm sure I've seen something like that before. Similar, I know it says MOS, so I haven't looked them up yet, but I reckon they're going to be powering the I haven't even looked where that is, what that one is that the motor? Yeah, YN motor and QB motor. I don't know where that one's power from, but anyway, let's not worry about that, because that might all be working. The fact is it's not turning on, so I think it has to be this, because there's nothing else on the board. This must be the main microprocessor or microcontroller. So let's Google that. Right, I'm really struggling because this is also all in Chinese, but I have got the pin out here. They're both, this one and this one are both 20 pin ones, just like this. And I'm not sure which one is what because they're both different. But this one ends in 145, this one ends on 145A. Mine does just end in 145. And I can see here pin 17 is ground and 19 is VDD. And if I go to pin 17 here, because we know that this is ground here, pin 17 goes to this side of the capacitor, and I can hear it here. So let's plug it in and see if we have voltage across that capacitor, because that is basically the input. And then we know that that chip is getting its voltage. Five volts. The chip's getting fed with 5 volts.
A head-scratching amount of time later.
He's got notes.
Right, I'm getting nowhere looking at the data sheet. It's so confusing. I found another company with the data sheet, but it's all in Chinese. There's a few bits in English, but they're only what the pins are. And I don't know. I struggle reading an English data sheet, so I'm not going to have a clue on a Chinese one. Right, this is what I want to do. I am going to put 5 volts in directly into this voltage regulator here. So I've got my bench power supply on, and I've got it set to 4.9 volts. I want to see, just in case that's weak. So now, which is the next? So the negative is this one here. So let's connect this one here. Right, so I am going to go to that side of the capacitor. Oh! Uh-oh. Oh no, Vince, you idiot. I think I'm okay. I just went onto the ground. Let me be a little bit more careful. There we go. Beep, but no light on. Interesting. Okay. So maybe that 5 volt part is purely for this, and maybe the 12 volts from the power supply is, doing other stuff. I'll tell you what we're going to do. Just in case it's a current thing, I'm going to put my bench power supply up, because I think it said it's supposed to be 5 amps, which is very high. What's it say on here? Yeah, 12 volt, 5 amps it says here. So that's 60 watts. But I suppose it would be if you've got heat and everything involved. Let me put this onto 5 amps. Bear with me. Right, 5 amps. And now let me go to 12 volts. Because all we did was measure for voltage. We didn't actually measure for any amp draw. Right, so that's 12 volts, 5 amps. There might be a spark. Yep, 5.1 amps. $12 volts. So now, negative here. It's very close. Okay, let's try to get this on here. Oh my word. Oh my word. They're all lit up. It seems to have seized up. Well, that's the first time we've had that. Maybe because nothing's connected to it. Oh, here we go. Ooh. Timer. That's changing colour. That's changing colour. That's changing colour. Air compression, there's 3 settings, I believe. Off, amber, and green. Oh, and red, maybe more settings. Heat and vibration. No way. Wow. It's a faulty power supply. Interesting that it doesn't want to recognise my fingers very much, but maybe it's because it's not in circuit. You know what I mean? It's not connected up and stuff. But clearly it's working through there. I would have never expected that. Okay, amazing. So, it looks like it's a power supply problem. had enough dealing with AC, if I'm honest with you. And that's going to be AC in there. See, it is 12.2 volts. Let's just see, just in case it needed some kind of like reset or something. Maybe it needed a higher volts to kickstart it. The higher current, you know. Oh my word. What? What have I done? All I've done is connect the bench power supply. And that's it. I wonder, will it work when we have everything attached to it? I wonder, Vince, should we put everything back on it and see if it works? Yes, let's do that. So I have had this before on an Xbox Series S. I connected up my bench power supply at 12 volts, and all of a sudden it was like a beep on, beep off, and all of a sudden, boom, it just worked. And then when I went back to the original power supply, it just worked after that. Really, really weird. And a lot of people said that there must have been some kind of tiny short on the board, and by connecting your bench power supply, maybe it wasn't as sensitive as turning off as the main power supply, and it just started to work. But the thing is, this power supply here, I think is always just putting out 12 volts. So I haven't got a clue why it's working. So we're going to get this back together, and then once it's roughly back together, let's see what's happening. Is it going to be okay? Okay, so I've got the board connected in down there now with all the connectors. I didn't need to refer to the pictures because they only fit in one way, so they're all idiot proof anyway. I just want to plug it in now before I put a million screws in, just to see if what happens. Right, so let's move that out of the way, and let's get the remote control, turn it on. There we go. Can you see the lights have come on? Turn the heat off. Nothing's rolling. These didn't roll there, so do we have more problems? Let's try vibration. Hold on, let's turn it on again. Okay. So what's vibrating? I can hear something vibrating. I don't know what it is. Is it not happy up here? Let's turn everything off a minute. And timer. Well, to begin with, this doesn't appear to be working. Right, leave it with me a bit. I'm not too sure what's happening here. I don't know whether it's because it's all apart or whether there is an actual problem. Okay, 100% vibration works. They're the cylinder things here. 100% the compression thing works, because you can see that's doing there. But I can't get these rollers to move whatsoever. So I'm thinking that the weird thing is I haven't even got any voltage when I put my multimeter into this bit here. So as far as I can see, this is the big massive motor, and it goes into this connection here. Now maybe I've burnt it out, but I think the motor's seized up. But now I don't think that the board is going to be actually working for this. Let's put it back onto the bench, and let's put voltage into this ourselves and see if we can get this working here. As far as I know, this is for the vibration at the front. That appears to be working. The LEDs are definitely working. The pump 100% is working because I've seen the things expand. The only thing which isn't working, which is the main thing, is there doesn't seem to be anything happening on this motor here. The weird thing is what is the odds of having two faults on something? But looking at this does look a little bit rusty. So maybe if it hasn't been used since 2021, when that circuit board was printed, then maybe the motor just needs to start moving in order to kind of get going. But I'm worried now because when I had it on, to begin with, it seemed to be turning itself off, probably because it measured some sort of overcurrent or something. But then at the end it wasn't. So I wonder now, have we blown out something on here, like these big MOSFETs or something? I've just unplugged a few things just because to take the pressure off. Also, I need to remember to put that back on. It's nice that they've put the the springs in this bit here and here, because there would be a chance of that kinking when they were making it, when they were putting the lid on here. So that's nice. Let's get the bench power supply and let's start at maybe 3-4 volts or something and see what's happening. I'm at 4.6 volts. Let's see if this will make it work. There we go, that worked. Did you see that? That's working. And that's just on 4.6 volts. I presume the actual one's probably on 12 volts. Okay, so we know that that's working. So if the motor's working on 4 point something volts, then 100% it's going to work fine on 12 volts, if that's what it's designed to work on. The motor isn't seized up. It must be something on the board that is not sending the voltage to the motor. See these massive kind of MOSFETs? Well, you can't see, but remember the two big MOSFETs? Hardest thing ever to film. Well, I've just got my lead to the negative where it comes in, and I'm just going on top of those big MOSFETs. There's two of them. I've got everything unplugged apart from the motor here, just in case it's a problem with the power supply not pushing out enough. Now watch this. You see here we have 12 volts. If I go to rolling, yeah, now we'll have no volts because that's off. And then there's two different settings, but both of them are reading 12 volts as far as the volts is concerned. Yeah, and then it will go to off. And then if I go to the other MOSFET on top of it, again off, and 12 volts. So we need to take that board out and find out why we haven't got 12 volts going into this. I'll tell you what, just in case there's a problem with the ground, let's go here. Have I got 12 volts? No, I haven't. So it's a problem with the ground of that connection. So now if I go to this ground on the incoming, I know you can't see any of this, and the connector for the 12 volts, let's see if we now have. We have 12 volts. So it's a problem with the negative. That's interesting. And off. So if we can get that negative sorted, this should start working. Excellent. Right, okay, that was interesting. Right, let's take this out. I don't think I'm going to be able to get the touch panel at the top working, because even at the very beginning, that was hit and miss. So, yeah, I don't think, but I don't care. If we can get this working with this, happy days. I actually need this for myself with the with this Advent challenge. I've never been so worn out. Time now is 3:15 in the morning, and I have to really get this fix done before I go to bed. Otherwise, I won't have time to edit it all up. It really is, it's trying. Right now, let's find out why we haven't got the negative. So first of all, I've already forgotten which one is the negative. So let's see. From here, it goes to here, yeah? So we've definitely got 12 volts here. Hold on. Hold on. What? But we had 12 volts on both of them. Oh. Now I'm confused. Now I'm really confused. Oh, and that's not the negative to there. Oh no. What's going on here? See, we have 12 volts to here when I'm using that as my reference to ground. I don't understand. If we go between here and here, we have our 12 volts. So what I thought was going to be straightforward has suddenly got a lot more complicated. It's always the case with electronics, is it not? So what I'm doing is I'm just testing various different components to see if there's a diode that's shorted, or if there's a cap that's shorted, or a resistor that doesn't look right. And then I spot this. Right, so this resistor here is like a complete short. This one's labelled up as R050, and it looks like a kind of a current sensing type of resistor, and it's 8,000 ohms. I don't think that's right. So I'm going to look up what R050 should be. Well, AI, which I'm not going to trust, saying that it's 0.05 ohms. Let's just see. Yeah, 50 milliohms. So that should be a direct short, shouldn't it? So that, I think, has blown over. Yeah, here we go. Look here. 0.05 ohms. So that's not right. And that is what feeds the pad off that one there. And that one. So that's not allowing the path through to feed these, to feed the motor. Do you know what I mean? Right, let's pop that one out with some hot air. Unless, of course, remember when I was down here and it sparked when I tried to put 5 volts in? Unless I put 5 volts, but it was only 5 volts. And I'm sure that these are going to be 12 volts for that massive motor. Because that's going to be the most powerful thing on here. Especially with somebody's big feet on there. So I don't know why this one here has blown. There seems to be loads of things here which are not really adding up. I mean, why did the thing even come alive in the first place? It's getting soft. So there we go, 88,000 ohms. How weird. Now, of course, I'm not going to have any of those resistors, am I? Let me just see what the what it's reading on the actual board. Remember, it's warm. 6,000. So there's no signal getting through there. There is no signal getting through. Right, I have from, remember the battery charge that I did, I have got these ones here, and these are 0.68 ohms. So I know that's a lot higher, but that's the closest I've got. So these are still under 1 ohm, but they're going to be much. Remember, the others was 0.05. So these are a lot higher. But let's pop one in. These are also kind of massive resistors, the same sort of one as that. And then I can always order these ones up from eBay. But for the purpose of this video, it'd be nice if I could show you it working at the end, even if it only works in the remote control. So if anything, I suppose this will put through a little bit less power, yeah? They seem to be the same size. This one is a bit fatter, actually. Do you know what I'm going to do? I'm going to put 2 of them on. Just in case this hasn't got enough, I think these are 1/4 watt, I think. I'm going to put 2 on. Also, that will bring down the ohms lower as well. Still way out, but a bit closer. Right, let me tell you what I'm going to do, because it's Christmas. I'll put the 3rd one on there. Okay. So now, I think because they are in parallel with each other, that will decrease the ohms and increase the wattage, I think. There we go. Fancy. Okay, let's clean it with a bit of IPA and see if the rollers start working. And now if we go across with our meter, before it was 85,000 ohms. So we're going to go from that leg to here. And now you can see, let's get a better reading. There you go. Under 1 ohm. Fantastic. My meter is, there you go, under 1 ohm as well. So, yeah, you can see it's reading different now than it was before. Right, so we're going to connect up the bare minimum. We're going to do this motor. We're going to do the input on the way in. And we're going to do this here. Let's see now what you can do. I wonder, will this start behaving itself? I very much doubt it. Let's plug it in. Let me see those rollers roll. I've got my hopes up now. Here we go. You ready? I'm going to plug it in now. I'm in. Let's see if this is working any differently. No. Interesting. Ah. Now it's not working. So did it start working because when I put voltage in it might have blown? Oh, here we go. Hold on. Ah, so maybe when that resistor blew, it started to work. So maybe there is some problem with this part of the circuit here. Let's unplug it and plug it in again, because that's the only thing we've done differently. It's exactly the same as it was before. So maybe at the beginning today, that R050 resistor was testing okay. And maybe when I put voltage into it, somehow I blew it. Yeah, it's exactly the same as it was earlier today. Well done, Vince. So after about 3 hours of work, you're in the same position you were when you started, but at least we have a little bit more knowledge. It's something to do with this current sense resistor, or in now, the 3 double-decker currents triple-decker resistors. So what we're going to do now is let's take out the resistors just to make sure it comes alive again, and then if it does, we know 100% the resistors are connecting up part of the circuit that the brain of the circuit, the microprocessor, doesn't like. So we have actually made quite a bit of progress, even though we haven't got it working yet. Let's plug it back in. See what you were going to do. Are you going to come alive? Yes, you are. So it is something to do with that. Yeah, so it's something to do with that. I wonder now, I'll tell you what we'll do. Now that it's supposed to be working right now, let me just lean over and try to put that in position. Let me just get the resistor. This is one of the working ones. Let me just try to place that on the board and see if it starts moving. Or will it go bang? There was a spark. Nothing's happening. I wonder, has that blown that resistor? Yeah, it's blown it. It's now 260 ohms. That's K ohms. 260 ohms. So, why is it blowing them? Okay, we are slowly making progress. So when there's no resistor in circuit, it comes alive fine, but clearly the motor's not going to work. When we put a resistor in circuit, it blows, unless we put loads of resistors in circuit, which can withstand, I presume, the fault that is being generated. So let's have a real close look at the board to find out what is actually happening. Right, so I've just been tracing back from here, and basically this one actually goes to the negative, yeah? So this is the negative of the incoming power, and it comes to here. So the reason this isn't working is because we haven't got the negative coming over here. It needs to go to here, but for some reason it's blowing. Now if you have a look, this goes to this one here, and it also goes to these two here, yeah? So you can see that pad there, and these two, but it doesn't come up, sorry, there and there. This one's different. It doesn't come up anywhere else, yeah? Oh, hold on. Well, it shouldn't be coming up there, because it's not coming up here, and these are identical. Can you see all the components are the same? So, hold on now. There. There. There, but not here. Right, this is different. Because basically from here it goes through here. This is measuring correct here, and then it goes into this microcontroller on that pin there. Right, let's do the diodes. So we get a reading, and we get a reading. So we're getting a reading both ways. Here and here. We're getting a reading here and here. Why is this one coming up as negative? And if that's correct, why isn't this one coming up as negative? That goes to there. That goes to there. That's our problem, I think. I bet this has blown up itself and it's got an internal short on these two, which is now putting it down to here. Unless, of course, it's supposed to. Maybe what's happening is we're getting power coming up this one and it's short into here, which is putting a short on here, which is blowing it here because this is negative. So this is acting as like a light bulb. Yeah? Do you know what I mean? If there's 12 volts coming up here, then it might be coming down here when it shouldn't be, and then it's going across here. Maybe that's the problem. I think we need to, let me look up what these are. Probably be another Chinese data sheet. Well, it's certainly been an interesting one, that's for sure. Now, if you have a look, so these are N and P channel enhancement mode field effect transistors. So MOSFETs. MOSFETs, right, okay. But they're N and P channel ones. And if you have a look, on my one, we've got S1, which is the source one, and the gate together. And then we have S2. So where's the drain? Oh, this is the drain up here. So we've got the source and the gate together. That's wrong. I'm going to take this one out of circuit. Continuity. Excellent. Can you hear that now? Nothing there. And these are shorted. Okay. Right, I'll tell you what I'm going to do. I'm going to just pop these two resistors back on. I can't be bothered getting the third one out. I just want to see if we have anything now with that one removed. Let's see if the lights come alive or not. So I double-deckered the resistors and soldered them back onto the board, and then I'm going to test it just as it is now, and then we'll put it back in the machine, and let's see if anything happens with the motor now that the faulty MOSFET has been taken out of circuit. Right, now let's see if the negative is getting across. So, negative from here should be coming here now. It is. And here, but not there, because it's not there, and not that one. Right, I think I'm going to put this back in. Well, I'll tell you what, let's just do it here for the moment and see if it comes back alive. We don't need to connect it anywhere else, do we? Just to see if it comes alive. Or is it going to burn those up again straight away? So maybe this isn't as new as I thought. And it's been pat tested, so... Are you going to turn on? Result, you are. Excellent, you're going to turn on. So now let's put it back into the machine and see if we have any life on the motor, or see if we have any voltage at the very least. Oh, what am I on about? I've taken away the negative. I've taken away the negative, haven't I? So of course it's not going to work. But yeah, it's not gonna work. Well, in this instance, I've taken away the positive. So if I was to go, hold on now, between the positive here and here, we've got the 12 volts. But if I go between the negative here and the positive, we haven't. Yeah, we've got 12 volts at the gate now. Okay. Yeah, okay. So yeah, that's the reason we're not gonna get anything, because I haven't got the positive. Oh, that's a shame. So if I was to go from the positive here, then we'll see it suddenly come alive. Positive in here. Because the microcontroller's turned it on, but we haven't got a path now through. So if I go between there and here, I think it's going to work. There you go. There you go. Right, let's just see the different speeds. So, off. That's probably low speed. And fast speed. Okay. Well, that's good. That is good. Is it going to make any difference on the touch in here? Wow, hold on a minute. So maybe the problem down here is also somehow linked to here, because look, it's now working. They're all working. No way. And off. Okay, so we need to get a new one of those. Results. Ah, that's good, that. And turn off. Fantastic. I think we fixed it. We just need a new one of those P and N MOSFETs and the correct resistor, and then it should be up and running again. So, what's the problem all along? The problem all along, if I tested the MOSFETs, I would have got it a lot quicker then. The problem all along was the MOSFETs, and the only reason it started to work is somehow I blew the resistor, maybe when I was inputting voltage, maybe my leads hit together or did something, and whatever it is, it blew the resistor, so it cut the path to that MOSFET, and that's why it livened up the lights. So the problem all along was the MOSFET. I'm certain of it. Excellent.
One smug sleep later.
You've still got it.
Okay, I'm just putting it back together just purely so I can finish up the video. I'm only putting in a few screws to keep it together. I've ordered up these from AliExpress. These big MOSFET things were dirt cheap. We're talking a couple of pounds for 10 of them. And then I've ordered up a big selection of current sense resistors as well, including the R050. Now, just to finish up the video, I'm just putting in a jumper wire from the incoming positive over to the positive that goes to the motor, because obviously we haven't got the MOSFET doing the switching now. So we're still going to switch via the negative one here, but clearly it's not how it should be done. So I'm doing this purely for the video. I'm not going to have this running for long. I presume maybe by doing this, the little microcontroller here can't measure the current that's going through it. So in a fault condition, everything might burn up. I'm only doing this purely for the video, just to show you it working at the very end. So I'm just going to put in a few screws and then we can test this out. Okay, here it is. I've just put about half the screws in just for testing. They definitely didn't scrimp when it comes to putting screws in anyway. Now, I just turned it on very quickly. I haven't actually tried it out yet. And amazingly, this is now working. So it looks like all the problems were related to this one MOSFET here. But luckily for me, because the current sense resistor went, it disconnected this MOSFET from the circuit, which allowed me to actually do the testing, because otherwise I don't think I would have ever found that. But here we go. Everything's easy in hindsight. Now I think, yeah, I should have just measured that MOSFET against the one next to it. It'd be unlikely that they're both blown. But I didn't. I was going all from the power switch because I was thinking it's not turning on properly. Anyway, if you watch this now, Got a little red light here. I'm not sure if you can see this or not. When I turn it on, I'm just going to turn off the feet one there. I'm going to turn off that as well and turn off the heat. So you can see it's working there. I'm not sure if you can see the lights lighting up or not, but that's the timer. And then feet. That is air compression, heat and vibration. So there we have it. It appears to be working. Let's see if we can do the air compression and let's see what happens. Oh, I need to turn it on. Right, I can feel the air compression starting to work, I think. Oh, I can feel heat. Fair play, I can feel heat. I can see a bit of a red light. Are these getting bigger? Yeah, look, can you see? They're starting to come out. Look at them grow! I don't know if you can see that in the camera or not, but they're filling up with air. They go so far and then they give a little bit. There we go, you can see they're touching now. Excellent. And when it comes to the rolling, let's just do that for a couple of seconds. That's rolling there, and that's rolling there. Next speed, and that's more intense. Turn that one off because I don't want to blow that remaining MOSFET. And let's put the vibration on. And these are the vibration ones up here. Right, I'm just going to put my feet in it. Here we go. After a hard day fixing. Woo! Fancy. Oh, it's too tickly. I don't know if I can... Oh yeah, I mean, it is kneading my feet. Let's do vibration. And now let's do the compression. I think the compression might actually already be done. That's got everything going on at the moment. Oh, and as the vibration isn't constant, it comes and goes. Yeah, do you know what, if I'm honest with you, it's probably not really my cup of tea. But then again, I'm quite ticklish on the feet. If you liked having your feet rubbed, you'd probably love this thing. So yeah, I thoroughly enjoyed that fix there. But luckily for me, the current sense resistor went. Otherwise, I don't think I would have been able to fix it. But now I know when I get that MOSFET in, well, I say I know, I'm 99% sure that this is going to be working absolutely fine. But if you know otherwise, you can add that to the comment section down below. Why it failed? Who knows? Maybe something got jammed. Maybe somebody tried to stand up on this when it was working and then maybe it overloaded the motor, which overloaded the MOSFET. Not too sure. Anyway, if you enjoyed the video, give it a big thumbs up. Fingers crossed, I'll be with you again tomorrow for another Advent fix. Take care, everyone.